I'm Joby Boxall from the University of Sheffield, representing the Environmental and Water Resources Institute WDSA History Project. The purpose of this project is to document the history of water distribution systems analysis. An important part of this project is a series of interviews with engineers, modellers, researchers and practitioners who've made a significant contribution to the field of water distribution systems analysis. Our interview today is with Vanessa Speight, who's now also at the University of Sheffield. She's been at the forefront of water distribution systems analysis since the late 1980s and continues to make a significant contribution. Her work has been across academia, consulting, and made a substantial contribution to the field. The interview is being conducted on the 3rd of September 2015 in Leicester in the United Kingdom during the Computing and Control for the Water Industry Conference. Vanessa, you've been working in the field for some time now, since the late 1980s. Late 1990s, get the right year. Can you tell us how you first got involved and attracted to the area?
Okay, well, how I got involved, I guess I studied civil engineering with an interest in water, and I was thinking back about why I even chose water. I think I was influenced partly. My father, who was originally an electrician, ended up working for the municipal water and wastewater system in my hometown. So when I was little, we went to the water treatment plant and got to play around there and enjoy it, which was fun. So when I decided I wanted to study engineering, but I wasn't really sure, I was looking through the course catalogs and flipping through the pages and reading different descriptions and ticking them, and it seemed that all the water ones were the ones I found were interesting and I wanted to study. So I studied civil engineering with a minor in environmental engineering, which then led me to my master's in environmental engineering at North Carolina. And that sort of launched me in the water field, but water distribution specifically, I really didn't start working until my first job after my master's, which was for Montgomery Watson in Tampa, Florida. And that was the early days of H2O-Net. And we won a project where we had to build a water distribution system model. So I got to work with Paul Boulos and the early development, version 1.0 of H2O-Net, and probably one of the first larger models that were built or was built with that software. So that was mid-90s.
So some of the very first modelling.
Yeah.
That's really cool. So from that, you then went on to do a PhD, focusing more on chlorine, but again with modelling involved. Can you tell us how you ended up doing that and why chlorine?
Yeah, well, I was interested in adding the water quality piece. I'd done hydraulics, sort of pure hydraulics for my master's and the work I'd been doing as a consultant, but the water quality and people's health and all of those other kinds of impacts interested me. So I was able to come up with a project idea that looked at water in terms of chlorine and disinfection byproducts, and trying to understand sampling, really, where should you sample, how should you be doing quality assurance for public health protection. And I had lots of different related water distribution projects during my PhD, but my thesis was that sampling analysis, yeah.
And then you've gone on to make a very successful career, continue that water quality angle. Very diverse career across very large multidisciplinary consultancy firms that specialise in water quality, then your own independent consultancy, and now to university. There's some pretty diverse sectors, about as diverse as you're going to get. Tell us something about the implications, what you've learned from those different areas. Maybe why you ended up at a university.
Well, that's a long question. Let's see. Well, it's funny because I feel like not many people actually still work in the field that their PhD research was in. So I work in that field, but yet from a bunch of diverse perspectives. So maybe that makes me a little unusual. I think there's a lot of reasons why I've switched around. I do like the variety, and I do like kind of focusing on a technical area, but looking at it from those different areas. So when I was in consulting, I was nationally based, and any sort of water distribution project that came up, I was working on. So I was traveling a lot. I was able to see how things are different in Phoenix than they are in Texas, than they are in Florida, and really kind of see some of those factors, I guess, that influence water quality all around. The traveling life is very difficult, though, so I was a little tired of that after a while, despite the opportunities and the international opportunities. I wanted to pursue a little more, so that's when I started my own company, focus a little on research, have some freedom to do other different kinds of projects. So I did that for a few years, which was rewarding in some ways, and also I really just found myself a bit bored. And when you're a small firm, you sort of have to take the work that comes to you. And I really wanted to get back into research more, have some more interaction with students and the cutting edge. And so I pursued the opportunity through my personal connection to the famous Professor Boxall that I was able to come to Sheffield, initially as visitor, but then decided to stay because I enjoyed that research environment and having a group of people to bounce ideas off of. And I think water quality and distribution systems is not a single person field. You have to have microbiologists and chemists and hydraulics and pipe mechanics people and operational people and data people, and you really just can't pursue that fully as a one-person show. So I like the diversity of the group and the different angles that it gets to bring in.
Fantastic, nice testimony to the group. You mentioned travel and international perspectives there. You've got a pretty unique range of experience from all across America, various other bits of the world, particularly when you were doing the large consulting work, and now in the UK. Are there any particular observations of how things are different, or maybe how things are the same and repeating world over?
Yeah, it's funny. I think things are the same but different. I mean, it's still the same job of putting water in pipes and pumping it around and making sure people have their service all the time, which is not an easy job, and so many of the public customers don't realize how actually it is complicated. Most days I think it's a miracle the water comes out of the tap. But I've been really interested in the UK with watching the private ownership model and how that influences the decisions that get made about operations, and how they're really counting their pennies so much more closely, which is sometimes good because I think it promotes efficiency, but then it's sometimes bad because it really it forces maybe cost-cutting measures that aren't necessarily in the public good, where a municipality in North America could choose to spend a little more because they feel it's the right thing for their customers. That doesn't really happen in the for-profit kind of setting. So it's interesting how that flows down through their organizations, and even down to sort of what samples do they take for water quality in the distribution system. It's quite different in those settings because of the governance and because of their structure of management. Not so much because of the water quality being different.
So do you think the regulatory differences that have to come in when you're privatised, we have to have a very different regulatory structure, whereas you got involved in the code for rules, etc. in the US before you left there. Did you see huge differences in the regulatory structures and pros and cons with those as well? Yeah,
I think so. The US, I think, is very nice in some ways because they're collaborative about how they develop their regulations. And the stakeholder negotiation process for changing the regulations is a bit long and drawn out, but it comes up with some really great regulations that everyone agrees to in the end. And that doesn't set up the same sort of us and them kind of thing that you see in the UK, where the regulators are seen as very much sort of the enemy by the water utilities, maybe rightly so because they have quite a bit of power. So in one way, I think also they could do more in the UK because they've got the ability to do that. I mean, they can really dictate almost anything about the operation, which doesn't really happen in the US. The US model is more about the end point result and meeting that, and there's no teeth to change an operation or change a practice. But the UK model could be used, I think, to bring about a lot of innovation if that was what they chose to do, which I don't currently see happening because they're worried about keeping costs low, but the potential's there. So from a customer perspective, I'd almost rather have the UK regulator getting in there and making things happen versus a softer, gentler, collaborative regulator, which is nice if you're a water utility, but maybe isn't serving the customer's needs quite as closely. It's really complicated.
Yes. You mentioned collaboration in there, as in collaboration between the companies, whichever country we're talking about. And both countries have their sort of central collaborative, allegedly coordinating functions, Worth and UK Weir. Any observations again on differences, similarities between those two? It's quite impressive in the UK when they are putting league tables, that they still manage to have UK WEAR and fund what they call collaborative research through that?
Yeah, that's true. I see them, actually I don't see UK WEAR and Water Research Foundation as all that different really, because I think they're trying to stay focused on the research and trying to just be really responsive to the needs of their subscribers, which, you know, it kind of results in the same sort of thing. Whether or not those subscribers are competing against each other in a league table or not, they still have the same sort of issues. So I guess I don't see the distinction quite as much. I do see the kinds of research that they're doing, because it's very driven by their customers, which are the utilities, often ends up being very short-term and practical, which I think has had a bit of a rebound on the research community, which is looking generally at longer term and maybe not so practical, but maybe also more transformative kinds of things. So in the US, you definitely see a move towards less utility participation in research projects, and it's partly their cost regime they're working in, but it's a bit unfortunate that some of the heyday of water research in the 80s, when there was a lot of government funding and a lot of utilities interested in really finding out fundamental things, that the pendulum has swung a little, that's not the case right now, but maybe it'll swing back, hopefully.
Maybe digressed a little bit away from you and your...
That's fine.
So getting back to you, you've had a diverse career across all different aspects, but kept on water quality and distribution. So what are the things you've achieved, you've influenced, you've been part of around water quality and distribution that you're most proud of, you hope you'll be remembered for in how many years' time?
Wow. I guess I've done an awful lot of studies for different water utilities, and I think if you do those well and you kind of emphasize the important things, that leaves its own legacy. I'd like to think there's a lot of cities out there that are hopefully building the right things because I help them analyze it in a good way. I think some of the work with EPA is really good too and leaves quite an impression. I worked on the guidance manual for the Stage 2 DBP rule and developed the sampling protocol methodology based on using a hydraulic model. So it's called the Initial Distribution System Evaluation, which was required that all utilities analyze their system and choose their sampling points for DBPs. And at that time, models were maybe not quite so prevalent, and there was a move amongst the utilities to say, well, can't we use our model? Why do we have to take a lot of samples to characterize our distribution system when we have a model? So working with the EPA and with a bunch of stakeholders from AWWA and other organizations, kind of came up with an approach of how could you use a model, and then wrote that up in guidance manual. And I find it cited a lot as sort of the standard of what should a model look like, how many pipes should be included, and some of the things we actually didn't really intend because this was for a very specific purpose, but it took on a life of its own as a sort of standard for modeling, which is interesting to see. But it has that stamp of approval because it's part of a regulation and came from the EPA. So that one is an interesting one to have been involved in. And then a sort of follow-on was a Water Research Foundation project on guidance on how to do water modeling. And just talking about it this morning with people at the conference even, that a lot of the focus, I think, in the early days was on calibration, and there was a lot of finger pointing, maybe saying, well, you just didn't try hard enough to calibrate this model, when hardly anyone was paying attention to the data quality, and you had pipes with missing diameters, you had all sorts of unknowns that went into the base model. Trying to get that to calibrate was actually very difficult work to do, and it's still the case today that valves are closed that you don't know about, and all sorts of data is still missing, despite, I think, a vast improvement in collecting that data in the last 10 or 15 years. But it's still interesting how the modeler sort of gets blamed for the poor data quality on the behalf of the utility, and you don't get to defend yourself very often to say, well, actually, if you knew all your pipe diameters, you would have a much nicer model. Point the finger back would be nice, but that's all right.
Yeah, good. You've made a very successful career in what is a very male-dominated sector. Are there any particular observations or words of advice you'd give any other women wanting to get into the field?
Ooh, words of advice, that's tricky. I I think personally, it didn't really occur to me that it was going to be a problem that, you know, especially in university, I felt that, well, I was just one of the other students and it was not a problem. And even when I started to look at distribution system water quality, there's quite a few women in North America who were leading the field, particularly in the 90s, people like Michelle Prevost and Ann Camper working on biofilms. And so it didn't feel like that was really a male-dominated area. But the hydraulics and modeling side of things really is. And so I was kind of like crossing over between the two groups, and all of a sudden going to the modeling conferences, there's 3 or 4 women there only. And that was a bit of a shock to my system. But I think the advice is really just do what you want to do and know that you're probably going to have some problems and you're going to have to figure out how to work with people, and some of those people are going to be difficult and not appreciate you, but that's probably the case in most fields, and you have to just get on with it and have your homework done. Do not show up unprepared. I mean, I think that the women who do end up staying in this field have to be really top-notch, because the pressures will just weed out the ones who don't care and aren't willing to be prepared and, you know, come to the table as the smartest person, and then you're allowed to stay. Sort of the the advice, I guess I would say. Unfortunately, you don't get to coast.
Probably true of a lot of people. Yeah, maybe more so for women. Over the course of your career, you've been involved with a huge variety of other people. Maybe it's interesting to look at some of the younger people and the people you've been able to mentor and develop, maybe particularly now working more in the university. Are there any particularly exciting things you're aware of, and people coming, things they're doing that's exciting you?
Oh, the sort of next generation of modelers. Well, I think I'm actually happy to see that there is a next generation of modelers, because it hasn't been an easy field to work in and to stay in, and especially the ups and downs of funding. And I know a lot of the students studying engineering are attracted to go write apps or go work for a bank. And, you know, so it's good that there's some dedicated people who see that water is an important topic and want to do this as a career. In terms of the technology kinds of things, yeah, I don't know. I think it's more just a new brand of enthusiasm and maybe kind of a more global outlook, and wanting to be in water for the right reasons. They're not doing it because engineering is a solid career, but they care about saving the world a little bit, which is a nice thing to have in the future generation of engineers.
Okay, that's good. And you mentioned earlier multidisciplinarity, and you talked about this new kind of challenge, thinking more globally. Are there any other big challenges, big pressures that you think we need to, as a community, to be focusing on in the next 10, 20 years? What's the next big thing you think is coming that we need to be addressing and thinking about?
Well, I think we need to be thinking about paying more for our water. This is one of my soapbox topics, but it's ridiculous that it's so cheap, and it's forcing us to do really not smart things about managing the assets, and it's probably going to explode in everyone's faces, but maybe we can avoid it if we're smart. But I really, whenever I meet people out on the street or in some other setting, I'm always trying to say we need to value this amazing thing that's delivered to our door all the time whenever we want it, and it's always safe and it's always good. So I'd like to see the pipes be replaced, particularly in the UK. I have another soapbox about that one, that you can try to keep them going for a little while, but you just eventually will have to face the reality of replacing it, and the longer you ignore it, the worse the problem gets. So maybe it's time to tackle it head on and not keep sort of hoping things might somehow magically get better through some magic technology, which there's lots of great research and there's lots of great technology, but it isn't going to just instantly fix the water distribution problems.
You see a big challenge in getting people to invest in pipe renewal,
yes,
but doing it before we have the catastrophic failures, the big impacts, the public health or the lack of supply.
Yeah, it would be nice. I'm not all that confident it will happen, but it's my soapbox topic that I will rant about to anyone who wants to listen.
Fantastic, thank you. Is there anything else you think the audience ought to know about?
No, I think they should know that water distribution systems are fun and they should come work with us.
Fantastic, thank you.